Radio check, radio check.
Yeah, class one is started, I think.
Loud and
Team
clear.
booking है.
Okay, guys, can we start now? Sorry, I was on
Yes.
also.
Yes,
Yeah,
sir.
okay.
Yes, sir.
So now, beta, this when you see a light for the first time or you see it for the last time, do not worry about these words, whether it is raising or first sighting. Is it dipping or last sighting? Don't get into the technicality of these words. Okay. Whatever somebody may say, don't get into technicality of this. Now, you see, we know that Earth is spherical. Earth is spherical. Okay. Now, what happens because of the spherical shape of the Earth? You can see only up to a certain distance because of the curvature. What am I trying to say? If you are, suppose here as observer 1, then to what distance can you see? You can see up to a distance where you draw a tangent like this. That means you can see maximum up to this point. This is the range of sea horizon for this observer 1. Yes or no, beta? Because after that, if there is anything here, you will not be able to see because that goes below your horizon. Am I right, beta? Yes or no?
Yes.
Yes, sir.
Okay. Now, if the height of the observer is reduced to O2, what happens? Is the range of sea horizon increased, decreased, or remains same?
Decrease.
Okay. So that means range of sea horizon of observer depends on observer's height, and in chart work we call it as height of eye, right, beta? Yes or no? Yes or
Yes.
no?
Yes,
Okay.
sir.
Now let us say this was not
Yes.
okay. Let us say this is not the observer, this is the object. This is object 1 and this is object 2. Now what happens because of the height of the object? Object 1 can be seen by somebody here, yes or no? You can see the object 1. Correct, beta? If there is an observer here at O1, can he see object 1? Yes. Why? Because of the height of object 1. But can he see object 2? No. Because for object 2, the observer is below the horizon for object 2. Yes or no?
Yes, sir.
Am I right, beta?
Yes, sir.
Right, sir.
Yes, sir.
Correct. That is the range of sea horizon of the object. Range of sea horizon of object. And this depends on height of object. That means the total distance to which you can see will depend on height of the object and height of the observer. Let me clear this slide and redraw the same thing. with the observer on one side and the object on the other side. Let's say we have this observer here, O1. This is the range of his sea horizon. Now what happens if there is an object here of this much height, object? Its horizon would be here. Correct, beta? Tell me, can observer O1 see object 1? Yes or no?
Yes, sir. Can see.
He can see. Okay.
Yes.
If the
yes,
height of object is reduced, can observer 1 see the reduced height object?
No, no.
No.
No, no, sir.
Okay. So that means this maximum distance at which this object can be seen by this observer depends on height of observer and height of object. And this range is called as the geographical range. Now you see, an object can be seen by the observer only when it is within the observer's geographical range. But if it goes below the geographical range, outside the geographical range, or below the observer's sea horizon, object cannot be seen. The best example is the sun. Sun at night is as bright as it was during the day. Only thing is, after it dips, after it sets, the sun goes below the horizon of the observer, and therefore a bright object like sun can also not be seen. So one criteria which is essential to be met is that the observer should be within the horizon of the observer. And this horizon will be decided by the horizon of the observer and the horizon of the object. Do you agree with me? Yes or no?
Yes, sir.
Yes, sir.
And this is called as the geographical range. This is only one of the ranges. So let's first introduce this and then we'll take up the next one. Under this concept, we use the maximum distance or range at which the light is first seen when you are closing towards the light, or when it is last seen when you are moving away from the light. Once you get to know this distance, then the circle can be drawn with the light as the center and the sighting range, first sighting or last sighting range as the radius, and you will get a position circle for the ship. For any object to be visible to the observer, it needs to be A, within the observer's geographical range, which I just explained. If the object is outside the geographical range, then however bright the light may be, like the sun, even that will not be visible because it goes outside the geographical range of the observer. And second, it should be within the luminous range called as the present luminous range, PLR. How to explain this PLR to you? Guys, if you have 100 watt, okay, take the sun only. On a clear day, the sun is bright, you get so much heat, so much light during the day. Same very day, if you have fog, do you see the sun? Many a times, no. Why? Because the visibility of the atmosphere has been hampered. Sun is above your horizon. Sun is as bright as it was before the onset of the fog, but you have stopped seeing the sun because the atmospheric visibility has deteriorated. So, does this mean that everything which is above your horizon is visible to you? No. Everything which is above your horizon need not be visible to you. Why? The best example is of the sun on a foggy day. Sun is above the horizon, sun is bright, but sun is still not visible. Why? Because the atmosphere visibility has gone bad. Second example, if you have a fog, okay, or you have whatever be the atmospheric visibility, let's fix the atmospheric visibility now. Now, if somebody holds two lamps, one 0 watt bulb, another 100 watt bulb, and he starts walking away from you, which bulb will you stop seeing first? Will you stop seeing both together, or you'll stop seeing one of them first?
Sir, zero
0 watt
watt.
first.
0 watt, you'll stop seeing first. Now, visibility is same for both. Both are above your horizon, but you are able to see 0 watt up to a lesser distance. You're able to see the 100 watt up to a greater distance. That means it also depends on the brightness of the object.
Yes, sir.
That means one is the object has to be above your horizon, has to be within your geographical range. But every object within your geographical range need not be visible to you. For that object to be visible to you, the object must be bright enough in the given atmospheric visibility so that you can see it from that distance. If the visibility of the object is hampered either because of its brightness or because of the atmospheric visibility, then it may be above your horizon, you are not able to see. Same lighthouse, if a ship is approaching the same lighthouse on two different occasions, on one occasion, the visibility was good. In the second occasion, visibility was bad. We all know that in the first case, the light would be seen at a greater distance compared to the distance at which it will be seen in the second case. This distance at which you can see light, because of its brightness and atmospheric visibility, this range is called as present luminous range, PLR. So there are two ranges that we have introduced. One is the geographical range, which is based on the range of sea horizon of the object and the observer. Second is the present luminous range, which depends on the brightness of the light and the atmospheric visibility. Do you agree with this, or you have any questions to ask?
Agree, sir.
Agreed? Okay. So basically what we have to do, if for an object to be seen, both conditions need to be fulfilled. What are the conditions? It needs to be within your geographical range, and it also needs to be within your PLR. Only when both are met, then the object will be visible. Even if one of them is not met, the object cannot be seen. Okay, so for an object to be visible to an observer, it needs to be meeting both the requirements of being within the geographical range and also being within the PLR. Understood, guys? Yes or no?
Yes, sir.
Yes, sir.
Okay. Now the geographical range I have already explained to you, and the geographical range can be calculated by this formula which is derived. It depends on height of the observer and height of the object. So this 2.095 is when the heights are taken in meter. So geographical range is equal to range of sea horizon of the observer, which is this one, plus the range of sea horizon of the light, and this gives you the range of sea horizon. This formula you'll have to remember. This is the range of sea horizon of the light. This is the range of sea horizon of the observer, and together that becomes the geographical range. Is that clear, beta? Am I clear?
Clear, sir.
Okay. So that means if I want to calculate the geographical range of the light, what should I have? I should have height of eye of the observer, and I should have height of the light. If I do not have any one of them, you cannot calculate the geographical range. Is that clear, beta?
Yes, sir.
So
Yes,
to
sir.
be able to calculate the geographical range, you need height of eye and height of object. This height of eye is given in the question. If it is not given in the question, you can look for it in the remarks on top of the question paper. If it is not given at any of these two places, then height of eye is not given. No assumptions to be made. No assumptions to be made. If height of eye is not given, then geographical range cannot be calculated. Am I clear, beta?
Yes, sir.
Yes, sir.
So where will you look for height of eye? First, you will look in the question. If it is
Question
not
on the
given in
top.
the question, you'll look in the remarks on top. And if it is not given at any of the two places, then geographical range cannot be calculated. Where do you get the height of the object usually in the chart work questions? You have to use the charted heights. Okay. So this usually comes from the charted heights, unless somebody gives you in the question itself. So if you have both these things, then you have to use this formula and get the geographical range in nautical miles using this formula. This geographical range will come in nautical miles. So please remember this formula and do not do it like this. Sometimes people do this height of eye plus height of object. This is wrong. Don't do that. They are separately because it's not the same. So please don't make these mistakes. Guys, I'll clear the screen and show you the screen. And if you have any questions to ask on the geographical range, let me know. Geographical range can be calculated only if you have height of eye and height of the object. Is that clear?
Yes, sir.
Then we come to the present luminous range. Present luminous range of a light is the maximum distance at which a light can be seen by an observer depending on the brightness of the light, that is luminous intensity, and the atmospheric visibility. Luminous intensity is provided to us, is covered. Okay, if you go to list of lights, you'll get in candelas also. But for us, the luminous intensity issue is addressed through nominal range. And where is the nominal range? This is the charted range of the lights. You just saw that white red thing where we were talking, and it was 22 by 18 miles, correct? This was the nominal range. What is nominal range? Nominal range is the distance to which a certain light, when we say certain light, then its brightness is fixed. A distance to which a certain light is visible in atmospheric visibility of 10 nautical miles. So nominal range is the range of a light to which it can be seen in atmospheric visibility of 10 nautical miles. Is that clear, Mitra? Is that clear?
Yes, yes, sir.
And
Yes,
that
sir.
is what is called as nominal range. If your actual visibility is 10 miles, then the PLR and nominal range will be same. If your actual visibility is better than 10 miles, then your PLR will be more than nominal range. If your actual visibility is less than 10 miles, the PLR will be less than nominal range. Is that clear, beta? Because visibility, poor visibility will reduce the range, better visibility will increase the range. Yes or no? Correct?
Yes, sir. Yes, sir.
Okay. Atmospheric visibility at sea, you can estimate. In exam, it has to be given either in the question or it has to be given on top. This has to be provided as far as question is paper is concerned. So that means if I need to get PLR, what information do I need? I need to know the nominal range, which can be obtained from the chart, and I need to know the atmospheric visibility. If any of these two things are not available, you cannot get PLR. To get geographical range, you need height of I and height of object. If any of these two things is not available, you cannot get GR. So don't worry whether it is raising or first sighting, or else it is dipping or last sighting. What is it that you have to do? If you have all the four things given to you, nominal range, visibility, height of eye, height of object, please calculate geographical range and calculate the PLR. How we'll calculate the PLR? We'll refer to the diagram in a while. Calculate the both and use lesser of the two. Why? Because the light can be seen only when both conditions are fulfilled. Am I right, Beta?
Yes, sir.
Clear, guys?
Yes, sir. Yes, sir.
Yes.
If you are not given any one of these four things, that means you are only able to calculate either GR or PLR. That means you do not have information to calculate both. You have information to calculate only one of them. Then whatever you have calculated, please use that under the assumption that the other thing is going to be more than what you have calculated. That the other thing will be more than what you have calculated. Is that clear, beta?
Clear, sir.
Yes, sir.
So there should not be any doubt in your mind. It was written as raising, it was written as first sighting. Don't get into this technical confusion which has been prevailing for decades now. The light can be seen only when both conditions are fulfilled, whatever word somebody may use. If I can calculate both, that is the ideal situation, and take lesser of the two and finish off the question. If you cannot calculate both for want of information, then calculate whatever you can and go ahead using it, whatever the terminology may have been used. Am I clear, guys?
Yes, sir. Yes, sir. Clear.
Okay. So there should not be any doubts in your mind what to use when. Okay, nominal range of a light is the distance at which it can be seen when
Sir, can you
meteorological.
explain that please again, that when we have geographical range and present luminous range, we have to use the lesser one?
So what is to explain? Tell me. What is it that you have not understood in this statement, beta?
Sir, you have shown that if you find out both geographical range and PLR, then we the one.
Sorry? Say again, beta. Speak up, man. I'm waiting for you to speak up now.
Sir, you were telling about the if we have both the ranges GR and PLR, then we have you to use the lesser one.
So what is it that you have not understood in this statement? That's what I'm asking you, no?
He's asking where to use.
What is it that you want me to explain, beta? I'm asking you that. So this is the statement I have made, and you are repeating the same statement. So what is it that you have not understood?
Why we have to use the lesser one, sir?
If your geographical range is 40 miles, and because of the visibility conditions or the brightness of the lamp, you can see something only up to 20 miles. So will you be able to see it the moment it comes above your horizon at 40 miles? Will you be able to see it? Please answer. I'm asking you a question.
Yes, sir. No, sir. Yes, sir.
No, sir. No, sir.
No, let him answer, not the person who has the doubt. Tell me, bhai. Will you be able
Yes,
to
sir. If
see?
we have the light above the horizon, then we can see it, sir.
Okay. Then why can't you see the sun on a foggy day? Sun is above your horizon during the day.
Sir, because of the visibility, sir, atmospheric visibility.
So then, but sun is above your horizon. No, as per you, you should be able to see it. As
But,
per your
sir,
statement, sun is above anything
condition
above
is-
the horizon should be visible to you, right? Yes or no?
No, sir, but there should be visibility should be clear, sir.
So then, which range factors visibility is my question then. Which range factors visibility? Arey, which range of the two factors visibility, bhai?
Luminous.
10 nautical miles, sir.
10 nautical mile. My question is, which range
Luminous range,
factors
luminous.
visibility?
Luminous range, sir.
Luminous range, sir. Luminous range.
Is the name luminous range? Have the two ranges that we have spoken about, was that luminous range?
PLR, sir. Present luminous range, sir.
Present luminous range.
Why the word present? Because we are talking of the visibility at that time. So now you tell me, you said when the light is above the horizon, it should be visible. At night at sea, if a vessel is approaching you, which navigation lights do you see first if it is coming from right ahead? Which navigation lights do you see first? Tell me. Tell me, beta. अरे भाई तो अंडरग्राउंड क्यों हो गया क्वेश्चन पूछ के देखो यार once I ask a question you have to respond. I cannot keep repeating the question 20 times, please. You just cannot
Sir,
throw the
masthead
question
lights
and
and
duck
side
then.
lights, sir.
Anji, first what will you see?
Sir, masthead light.
Why? Why? Why, beta?
Because उसकी
You're right,
visibility ज्यादा
masthead
होती है
lights,
Sir,
sir.
but
because
why?
of height.
Height only? No. Not
उसकी
only height.
visibility sir, intensity ज्यादा होती है sir. Luminous intensity ज्यादा होती है.
What ROR में have you studied the range of masthead light and side lights? Which one has more range?
Sir, master
Yes,
light.
sir. Yes, sir.
So now as per you, the vessel is above your horizon. As per you, all the four lights should be visible at the same time as per your concept and theory, right? So I have given you two examples. On a foggy day, you can't see the sun. Now I am saying, when all the four lights are above your horizon, why can't you see all the four at the same time? At the same distance? Tell me, beta.
Because of their intensity, sir. They have
So
different
that means
intensity, sir.
that means the statement that you made that anything and everything above your horizon should be visible. Is that correct?
No, sir. It depends on their.
It also depends. It not only depends, it also depends, right? On present luminous range, correct?
Yes, sir.
Correct,
Yes.
beta?
Yes, sir.
So for anything to be visible, first it should be above your horizon, which means it should be within your geographical range. Second, it should also be within your present luminous range. Am I right? So if it is this and this, when will both conditions be satisfied? At the lesser of the two or greater of the two? Both conditions will be satisfied when?
Lesser.
Lesser of the two.
Fair, bhai.
Lesser, sir. Lesser. Okay, sir.
तो लगता है बीच में कहीं गायब हो गया था एकदम सडनली तू सो के जगह मेरे को लगता है सडनली यू सेड लेट मी मार्क माय अटेंडेंस टुडे चल एनीवे Nominal range of a light is the distance at which it can be seen when meteorological visibility is 10 nautical miles. PLR, so geographical range, how do we calculate? By that formula 2.095 under root height of eye plus 2.095 into square root of height of object. In some books, you may find 2.08. Don't worry, you can use that, or the latest books are using 2.095. The difference is because of the refraction formula that has been used. So that has led to that slight difference. So don't worry about that. Okay. How do we get the PLR? PLR we don't calculate with a formula. We use the luminous range diagram. I have already shared you in my notes that instructions for chart work, correct, beta? This
Yes,
is
sir.
already shared with you, correct?
Yes, sir.
Yes, sir.
In this, on one of the axes, in this case, it is on the upper axis, you have the nominal range. These are nominal ranges. This is PLR. And these are the visibility arc. So if you have a nominal range of 22 miles, you go on 22 miles. If the visibility is 2 miles, you come to 2 miles arc. Where it cuts it, you come horizontal on this side. And whatever you read from here, this will be the PLR. Is that clear how to use the luminous range diagram, beta?
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir. Yes, sir.
Yes, sir.
Okay.
I
So
just want to add one thing, sir.
yeah. Tell me, beta.
Yes, sir.
Go
got it,
ahead. Go ahead, beta. Okay.
Sir, like
Beta, you're
PLR
cutting, you're breaking off. You're breaking off. Just come closer to the mic and speak.
yes, sir. Like sir, the PLR is coming right now approximately 6.5.
Yeah.
So for exam purpose, like how much leeway we can take, like 0.5 up, 0.5 down. Like is
Beta,
there anything?
it depends on the scale of the chart, actually, scale of the latitude scale. What is
So
the
like
best
right
least
now,
count you can take from there, right?
yeah. So right now it came around 6.5. So for exam,
Because whatever you'll read from here, you'll use it on the chart. Am I right?
yes, sir.
So from here, you read whatever best you can. Don't compromise on the reading.
Okay. Understood,
Whatever best you can read. So if something is here, obviously it is 7. If it is in between, it is 6.5.
Yeah.
It is here 6.25. So read as best as you can, beta.
Okay.
You can read up to 1 decimal place to answer your
Okay.
question. Read
Okay,
up
sir.
to 1 decimal place. Okay.
Okay. Thank you, sir.
Okay. So that is how we get the PLR. So guys, again, just to repeat for the last time on this issue, we'll come to this later. Don't worry about the terminology used. Okay. If you have height of eye, you have height of object, that is a light. You have nominal range of the light, and you have the visibility. If all the 4 are there, using these two, please calculate GR. Using these two, please obtain PLR and use lesser of the two.
So I have one question.
Yeah, tell me.
Like so some surveyors say that while if question is there regarding raising or dipping, that is only for daytime. And
What?
means we have to calculate only GR. No need to calculate PLR.
Better tell me one thing. Is daytime the visibility does not play a part?
Yeah, only daytime, sir. Means
No,
only
but
for
tell me daytime, does visibility play a part? Yes or no? So
yes, sir.
during daytime, light cannot be seen. If you're talking of a lighthouse, then there is no way you can calculate its PLR. Why? Because it does not have its own luminosity. It's purely dependent on the atmospheric visibility. I have not seen any question in MMD exams where the questions are not pertaining to light and they're pertaining to lighthouse.
Okay. So my question is only that if the question is given raising or dipping, if there is mention raising or dipping, we have to calculate both GR and PLR. That's correct.
What is it that I have said at least 3-4 times, but I have said the same thing
Yeah,
4
yeah.
times.
So
now.
you have said that if the required information is given, height of object, height of observer, and all,
Correct.
we have to calculate.
Yes.
But the question is that, sir, because in raising or dipping, we can only see during daytime, not in the night time.
No, but tell me, how can you get the raising distance during daytime if the visibility is 0? Then what do you do?
Yeah, sir. Now that's I come to know that when you told about the fog and all that.
Yeah.
PLR,
So
that
then
visibility. Yeah,
then that means a lighthouse which may have come over your horizon when it was 20 miles off, and you see it at 2 miles off, and you'll draw a circle with 20 miles radius.
So that's I just want to confirm.
No,
that,
I'm just counter questioning. No, beta. The best way to learn is when I counter question and make you realize that there is a gap. Then, right?
Yes, sir. That's correct.
There is a clear gap. No.
Yes, sir. That's correct, sir.
Correct. What we are saying is, if my height of eye is 20 meters or whatever, and suppose height of light is 50 meters, you are saying this light, whether it is perfect visibility or it is restricted visibility or whatever, you are saying daytime, the raising as per your concept should be at this range, come what may. No, that can never be the case. This statement does not hold any water. Yes or no?
Yes, sir. That's correct.
If the visibility is poor, how can it be taken as raising at this distance? You may see it only at 5 miles, but this may be coming at 30 miles. Then what do you do?
Yes, sir.
No. That's absolutely wrong. This raising, first sighting, don't worry. This is not a new confusion. It was a confusion when we wrote our competency exams. It still continues. And don't get into, that's what I started with. Don't get into the technicality of the terms. A light can be seen, an object can be seen only when it is within your geographical range, together with being within your luminous range. Yes or no?
Yes, sir. That's correct.
Otherwise, it will not be visible. Yeah. Okay, so don't worry.
Okay,
Surveyors can
Thanks, sir.
keep going in circles. You can keep going in circles, but that is the reality, boss.
Yeah, thank you, sir.
Okay. Let's look at this question. Hookhead light was first sighted. I'll tell you one more good example. If you see my latest video, which is on SFVM of a cantilever, which was posted about 2 weeks back, I taught something in the phase 2. And then the phase 2 students came to me saying, sir, this topic has been taught like this to this institute, to this institute, to this institute, and they named 3-4 good institutes, and they said they are all doing like this. I said, yeah, if they are doing like this, I can't comment on them, but I can give you reasons why what I have taught is correct. So I just told them that. And then they said, yes, what you're saying is correct. Now, then what I did was I called up one of the leading institutes, the person who was teaching. I told him, I said, there is a gap in the cantilever that you are doing, and that is leading to confusion. And that what will happen is somebody will suffer. Maybe
Yes, sir.
somebody submits a wrong answer and to the MMD, and people who have done right may be marked wrong and may fail. It took me almost 10 minutes to convince the person. And then I said, now I'm releasing a video. You please go through this video, circulate it to your boys, mend the ways. And the whole idea of putting out that video in the public domain was that let somebody now say that this video is wrong. Problem is, if something which is prevalent has been learned wrong by one of us, by me also, what will happen? Unless somebody corrects me, I'll continue living with that belief. Am I right, beta? So that is what is happening now.
Yes,
That's
sir.
unfortunate. Yeah. And that's why that video was released. Anybody who's done phase 2 stability last batch with me and in this
Yes,
group?
sir. Harpreet, sir. Harpreet.
So Harpreet, you know what
Yes,
happened about that
Yes,
cantilever thing,
yes,
right?
yes. I remember, sir.
Yeah. And then after that video was released, those
Yes,
people
sir. We
sent
shared
out to their
everywhere.
boys, and now the boys have realized. Now, though the same boys reached back to their institute telling what is the correct way now. Now let them say what is the correct way. So, beta, if there are some myths which are floating around, that is unfortunate. There is no answer to those things, you know. Anyway, let's not waste our time. Whatever is beyond our control, let's leave it out. Hookhead light was first sighted at 2000 hours in atmospheric visibility of 2 nautical miles. If the height of eye was 12 meters, draw the PC at 2000 hours. Identify hookhead light that is there. What are the characteristics? Flashing 3 seconds, 46 meter, 23 mile, on 2, 45 seconds. I'm sure in this you know 46 meters, small m is the height. 23 capital M is the nominal range. That means if visibility is 10 nautical miles. Charted height is 46 meters, you can see. Nominal range is 23 nautical miles. We have to calculate GR and PLR. Height of eye was given in the question. Here is the luminous range diagram. Nominal range is 23 miles. GR is calculated here. It's 21.5 nautical miles, guys. Then you see PLR being calculated. You go on 23 miles nominal range, come to 2 nautical mile visibility, go across to the PLR scale. And what do you find? PLR, what best I can read is about 6.7 nautical miles. If you want to read 6.8, that's fine. No issues at all. And what do we find? PLR is less than GR. So PLR will be the first sighting range. PLR will be the first sighting range. So with hook head light as the center and radius as 6.7 nautical miles, we can draw this position circles. You don't have to draw this part of the position circle. I didn't clear it off. You just draw the required position circle, and that's the PC by first sighting. Is that clear, beta?
Yes, sir.
Yes, sir.
Okay. Okay. Now we come to the last of this. PC by high altitude celestial observations. Now, when we did the celestial PLs, I said the celestial PLs are actually small part of a position circle. Which part? The celestial PLs actually give you a PC. Celestial observations, sorry. Celestial observations actually give you PC. And for PC, you need center and you need radius. We just started with that today. In celestial PCs, what is the center? Center is the geographical position of the body whose site has been taken. So GP is the center. What is the radius? It is TZD in minutes is the radius. Normally, when we take sites, what is the altitude of the object? Maybe 30 degrees, maybe 40 degrees, maybe 50 degrees. That's the normal altitude you get. So even if I take 50 degrees altitude, TZD becomes 40 degrees, which is 2,400 miles. That means I'm talking of a position circle with GP as the center and a huge radius of 2,400 miles. That means I'm talking of a circle with very less curvature. Because the radius is huge, the curvature will be less. Now, what else do I have? I have the azimuth. That means as the body is somewhere in the direction of the azimuth. If the azimuth is this, if this is the azimuth, that means body is somewhere here on the position circle. Why it is not here? Because there will be, you have used DR lat or DR long or DR position for calculation. So therefore your results are not accurate. but the ship will be somewhere in this part of the arc in the vicinity where the azimuth is cutting this circle. Now, since this position circle is with a huge radius, which means it is with a very less curvature, then this small part of this circle can be taken as a straight line. And it is this straight line that we use as celestial PL. This is what we had. And then this celestial PL, that's why you draw it perpendicular to azimuth. It is this part of the circle that you draw in celestial PLs. Okay. But what happens is, if the altitude is high, that means, let us say the true altitude is, let us say 89 degrees, 56 minutes. Then what is the TZD? TZD is only 4 miles. In contrast to 2400 miles here. Now, when you draw a PC with a small radius, here is the GP of the body, and you draw a circle with small radius of 4 miles, and now you draw the azimuth. Now, because of the huge curvature, you cannot take this part as a straight line. That will induce more error. Therefore, in such cases, we do not draw the celestial PL, we draw the celestial PC. Have you understood why do we draw a celestial PL when the altitudes are high? Understood, guys? Is that clear?
Yes, understood.
Yes, sir.
What is the center of this PC? GP of the body, geographical position. What is the radius? It is the TZD. So when we deal with it, we actually draw the PC when it is high altitude. Otherwise, we draw them as PL, as we had studied under the PL section. Now, geographical position, if you go through chapter 5 of Principles of Navigation, if you join the body, celestial body center with the center of the earth, wherever that line will meet the earth's surface, that is the GP. That means if you bring down the body on the surface of the earth, it will come down at its GP. So what are the coordinates of GP in that very chapter of chapter 5 of Principles of Navigation? The latitude of GP is always equal to declination of the body. Whatever is the declination, that will be the latitude of the GP. The longitude of the GP depends on GHA. Why? Because longitudes are measured up to 180 degrees east and 180 degrees west. But on the celestial coordinates, you measure GHA, which is measured only in one direction from 0 to 360. So longitude is connected to GHA, but it cannot be directly correlated like the latitude. If the GHA is less than 180 degrees, then longitude is equal to GHA and it is named west. Why? Because GHA is measured westwards. But if GHA is greater than 180, then guys, longitude is 360 minus GHA and is named east. This is how you get the lat and long of the GP. I will not take you through more theory as far as chart work is concerned. This is good enough for us to execute our part. More you can go through chapter 5. If you want more details on it, you can just mention it to Sunil in your navigation class and he should be able to take it more. But I have given you an overview of why celestial PC, part of the celestial PC is used as a PL, straight PL, and why that assumption will fall flat if the TZD reduces because of high altitude. Am I clear, guys?
Yes, sir. Yes, sir.
Okay, now I'll take you through these notes then. The celestial position lines that we learned to plot in the last class are a small part of the position circle drawn with GP of the body as the center and TZD as the radius. When observations do not involve high altitude, the TZD is reasonably large. So the straight line PLs plotted earlier represent small arc of the PC with very less curvature owing to large radius. In case of high altitude observations, the TZD is small. In such cases, the TZD, that is the radius of the species, becomes small, and then part of the arc cannot be considered as a straight line. In such cases, we draw a PC with GP as the center and TZD in minutes as the radius. How do we get the GP coordinates? GP of the latitude is always equal to the declination of the celestial body. Longitude is, if GHA is less than 180, then it is equal to GHA and longitude is named west. If GHA is greater than 180, longitude is 360 minus GHA and longitude is named east. That's how we get TZD, we all know, is 90 minus true altitude. You can take a screenshot of this if you want, but this is how the GP will be obtained. And now we have this example which follows. Question. Star X with declination 51 degrees 21 minutes north and GHA of so much was used for celestial observations. The true altitude was observed to be 89 degrees 54.6 minutes. Draw the vessel's position circle at the time of observation. You cannot use celestial PL here. GP of the star will be equal to, the latitude will be equal to declination. And since the GHA is less than 180, then longitude is equal to GHA and named west. So these are the coordinates of the GP. On the chart, we will mark the GP. Here is the GP, guys. This is the longitude, whatever it is, and this is the latitude, whatever it is. So here is the GP. So this is the center of the circle. What is the radius? 5.4 miles. I take compass, go to latitude scale, open 5.4 miles here, come to the GP and draw a circle. And this becomes the position circle with GP as the center and TZD as radius. So this is a position circle with, in case of a high altitude celestial observation. Is that clear, Beta?
Yes, sir.
Yes, sir. Yes.
Okay. So this will apply only in those cases. I have not seen a question of that type coming, but always be prepared. Pata nahi kaun kya dalte, but so it's all no harm in knowing it, so that you are always able to recall what is GP, how to get the GP, and how to basically plot the PC. So guys, with this we come to end of it. We have done 1 by radar range PC, second by vertical angle, third by horizontal angle, fourth by raising or first sighting, and when you're going away, the same thing will be dipping or last sighting. And then we have done high altitude celestial or high alt celestial observation. These are the methods of PCs we have done. Now, what we have covered until now in the 2 classes is various methods of getting the PL and various methods of getting the PC. Please go through, I'll share the video also. The same thing, it's exactly the same. So you'll get to hear the same thing what I said today. You can go through it. If those who feel the need of it, if you're comfortable, it's okay, don't waste your time. And in the next class, the third of the investment sessions, we'll talk about current and wind.
Excuse me, sir.
Yeah.
Yes, sir. Many videos cannot able to open on your YouTube channel.
Beta, some
600
videos
करो
are
भाई,
for
600
members. Okay. So what the one I'm going to send is you'll be able to open. The current and wind you will not be able to open, so don't worry. I'll be covering in the class. Okay. So उसका बेटा YouTube के साथ you'll have to take the membership with YouTube. So if you want to access them, otherwise In any case, we are covering it in the class. You don't have to worry about it. No issues.
Okay, sir.
Okay. So next will be current and wind, beta. And current and wind is, once you've understood PL, PC, and you understand current and wind, guys, you may not have done any question. Don't worry. Your 40% chart work is practically covered through these 3 lectures. Because if these 3 fall in place, then you will just run through chart work. Maximum problems happen because people forget what they've learned. They try to learn something which should have been built on the prior learning, and then foundation being shaky, everything falls flat there. Current and wind is another one thing. Uske baad se beta, so one more lecture, chart work as per schedule, and the class thereafter we'll get going with the plotting. So by then, please source the charts, especially 5048, because when the plotting is reached, you should be in a position to get going with the plot beta. Okay.
Copied on that, sir.
हाँ ठीक है और बताओ.
सर एक रिक्वेस्ट थी. सर ये 5048 आप एक वो ग्रुप पे शेयर कर देंगे मुझे सिर्फ
अभी लो बेटा शेयर रिक्वेस्ट की क्या बात है. एंड इफ एनीबॉडी हैज एनी अदर थिंग टू से प्लीज कंटिन्यू. आई विल जस्ट डू इट राइट अवे.
सर ये 5048 बेसिस पे कौन से मतलब बुक में क्वेश्चंस मिल जाएंगे प्रैक्टिस के लिए?
बेटा ये सब बुक्स में मिल जाएंगे तुम्हें, ये पास पेपर्स में मिल जाएंगे. ठीक है ना. बट तुम्हें क्यों चाहिए क्वेश्चन में दूंगा ना, तो टेंशन क्यों कर रहा है इतनी.
ओके सर.
व्हाई आर यू सो वरीड?
सर मैंने ना स्टार्टिंग का 5 मिनट मिस कर दिया था, तो सर
तो मैं वीडियो भेज रहा हूँ ना बेटा, वीडियो देख लेना ना बच्चे.
नहीं सर वो समझ आ गया मुझे. मैं बोला सर शेड्यूल में आज नेविगेशन क्लास थी पर आज चार्ट वर्क की हुई है,
तो उसके बाद तूने बीच में मैसेज मिस कर गया. तो
शायद मिस कर दिया होगा सर. मैं
there was I have to travel on Friday. That's why I swapped the class so that there is no miss out on the session. Friday will be navigation.
Okay, understood, sir.
Friday will be navigation. I had put the message. Maybe you missed it out, beta. Okay.
Thank you.
Sir, I have one mistake.
अब बोलो यार, मैं सुन रहा हूँ, तुम बोलते रहो, मैं जब तक वो तुम्हारे चार्ट भेज रहा हूँ.
सर मेरा क्वेश्चन ये है.
हाँ.
तो मेरा क्वेश्चन ये है कि ये जो सर हमने जो लास्ट में डिस्कस किया है रिगार्डिंग द हाइट ऑफ लाइट हाउस, द लेंथ, द हाइट ऑफ द लाइट हाउस वाज 59 meters. And sir, just I want to know in further question, the height of the lighthouse can be reduced or no?
Reduce मतलब in what sense, beta? I didn't get your question.
Yes, sir, because as per in the chart, height of lighthouse mentioned is 59 meters.
Yes.
And as per question, 1 meter tide below mean high water spring. So we add 59 plus 1.
Yes.
So sir, maybe any question.
You are saying can the tide be above mean high water spring? That is your question.
Yes, sir. Yes, sir.
Beta, I told you, normally under normal circumstances, it is not expected that